Hello everyone, welcome back guys. Hope you all are doing well. This is Mohammad Badruddin back again with another module from Web Security Academy. We are covering advanced topic and the previous module was server side template injection, which we already covered and we solved all those labs. Now today I am going to start web cache poisoning. So let's go and we see what it is all about. So before diving deeper into it, this little disclaimer as always for you, and I'm pretty serious about this. These all videos and these contents are only for educational and awareness purpose, and I do not support any unethical or illegal act. That's been said, to understand this complete picture about web cache poisoning, about this vulnerability and how to exploit that vulnerability, I would like to segregate all these terms in little pieces, and then at the last we will combine all of them and understand what this vulnerability is all about. So here I write few questions like what is cache. You may already know about it, but even though I will take just 1 minute to explain all of these. So what is cache? What is the purpose of web cache? How web cache works, and what is poisoning, and at last what is web cache poisoning. So you may get some definitions, more technical definitions about all these, but my purpose is to make you understand the fundamentals and the general, to give you the general idea. So if we talk about the cache, so a cache is little memory, or you can say a little storage area that stores temporary data and information. And if we talk about the web cache, so as well as the name is concerned, that means web cache means you are going to cache, or you are going to store small data or small documents for your web service. Fine. Now the question is, what is the purpose of web cache? Okay, why we need web cache, or why we need cache? So this, I think, we understand more better by this picture. So suppose this is a website, this is your web server or a website server. Okay, and just do not consider this cache. Suppose there is no cache. Fine, this is just a web server and these are the end users. So what happened, the websites like google.com, facebook.com and any famous websites, what happened, they may handle 10,000 of requests in a single second, or maybe more than that, maybe 50,000 requests in a second. But because of the popularity, what happened, they get hundreds of thousand requests in a second. Fine. So the first 10,000 requests can be handled by the web server, but rest of the requests are going to be stacked here. And maybe until your request reach to process on the web server, maybe that request get times out. So that is the huge problem. And at that instance, the latency problem came and user feel that the web service is very slow. Fine. And this also caused the bottleneck condition for the websites. So to solve this problem, we use cache. But before going to cache, I just mentioned one term, that is latency. So latency actually a small period of time, or you can say the amount of time the server takes to process a request and generate the response. Fine. So because server will take too much time to generate the response, and user have to wait for a long time to get the response, and maybe if there is bottleneck, or maybe if the latency rate is very high, so maybe user will get the request timeout. So to solve all those problems, we use cache here. And what this cache do, this is our another question, how that web cache works. So now the thing is, suppose we put a cache server in between users and the web server. So for user will not know that whether there is cache or what is your infrastructure. They don't know about this and they don't care about this. But the thing is, if we put the cache in between these two, any request come that is attended by this cache server, and cache will see whether the response of that request is already exist in my memory or not. If the response of this request is not available or not stored in the cache, then cache will send that request to the website server, and website server generate the response for that request and send it to the cache. Cache store a copy of that response and also send that response to the user. Now next time whenever any user make the same request, the cache will match the request and it will see, okay, the response is already stored in my memory for this particular request, so it will send the response to the user for that particular request. Now keep in mind what I just said, that any user after caching, after saving the response in the cache memory, if any user send the same request, okay, then cache see, okay, this is the same request. So how cache will know that this is the same request? That means there are something defined inside the cache, or maybe the cache is smarter to match the request and to identify the request, whether this request is same for what I have the response or not. I will broad this picture. Now suppose behind this cache there are 3 websites, and all these 3 websites have different requests because the host header is going to be different for all these websites. So any request come for these websites, the host header is going to be different, and maybe the endpoint is going to be different. So how cache will know that this request from this user came for this website, or this website? And I have already stored in my memory the response of it or not. So these parameters with which a cache identify the request, these parameters are known as keyed cache, and rest of the headers are known as unkeyed cache. I tell you here. Okay, so if any request, whenever we capture the request in the Burp Suite, we see something like this, http/1.1. okay, and then the second host header here is going to be host, and here we see www.test.com, something like this. And then there are other headers like we can say cookie, it could be other header like user agent, it could be accept language, okay, and a lot of headers. It could be any header, but the thing is the cache is going to identify the request from these 2 lines. Okay, so these 2 lines are known as keyed cache, and rest of the headers are known as unkeyed cache. Fine, so it doesn't matter what you have here. Okay, let's say there could be any non-standard HTTP header, or you may also add something here, but the thing is cache will check only these 2, and here the problem begins. Fine, so I will come to that point a bit later, but my purpose was to make you understand what is keyed cache and what is unkeyed cache, because these 2 terms are very, very important to understand in terms of web cache poisoning. So now we also know what is keyed cache and what is unkeyed cache. So let's see. Now the thing is, what is poisoning? Poisoning means to feed false or malicious information, and this is what exactly we are going to do. We are going to feed malicious response in the cache. So once the malicious response is stored in the cache, any user come with the same request, it is going to send the malicious response to the user, and then in the user end that malicious response may have some kind of JavaScript or something that is going to be executed on the user end, and that's how this vulnerability could be exploited. So we will see that in a minute, but here let's see. Okay, so what is web cache poisoning? Web cache poisoning is an advanced techniques whereby an attacker exploits the behavior of a web server and cache so that a harmful HTTP response is served to the other users. Exactly what I just mentioned. Okay, so in web cache poisoning, there are two phases. In the first phase, the attacker has to get the response from the backend server in such a way that that response contains some malicious code. It could be anything, but it should be malicious. It depends on the purpose, what kind of exploitation this hacker is going to perform. Okay, we will come into that, but for here to understand, just there is a first phase in which the attacker has to get the malicious response from the backend server, and once that malicious response is memorized or stored in the cache, what happened next? Any user come with the same request, the response will be served to rest of the users, and that response is malicious. Fine. So there are two steps, and I would highly recommend to read all these theory part, because this is very, very important. So now there is a thing. A poisoned web cache can potentially be devastating means of distributing numerous different attacks. And what kind of attacks you can perform by exploiting web cache poisoning is exploiting vulnerabilities such as XSS, which is cross-site scripting, JavaScript injection, open redirect, and so on. Fine. So there are two research papers here, and again I'm highly recommending you guys to read these two research paper, because this is very, very important, and maybe you understand it more clearly once you read it. Okay, and if you do not understand anything, do not panic. We will also cover the labs, and while solving the labs I will also explain everything. We also explained keyed cache and unkeyed cache, and we will see that again into the labs. Okay, here is the thing. Constructing a web cache poisoning attack. This is again the most important part. As I mentioned earlier, there are two stages, and actually both of those stages can be also defined in 3 points. Like, first of all, you need to identify and evaluate unkeyed input or unkeyed cache. I also mentioned that before, that whatever cache will not see to match a request is unkeyed. So cache will see only these two lines. It could be more. There should be more parameters, but for general purpose I am telling you, suppose for an example, the cache is going to see just these two lines to match the request. So rest of the headers are going to be unkeyed. So first of all, you need to identify which unkeyed input or what kind of header you can put here, and the application or the web server respond for that header. So what you do, you put here or you inject here that header in the request, and you send that header with the value in the request to the web server, and you will get the expected response from the server. And if the server give you the expected response, then fine, you can do your task. So now suppose you get the expected response from the server, then what you will do, we actually also cover this to get the harmful response from the backend server. So first of all, unkeyed input, and if you found the unkeyed input, then you will try to get a harmful response from the server, and that response you want to cache in the cache memory, so that any user come to access that web service or website, so that response will be served by the cache to all of those users. And think this attack as a bigger picture, like a very famous website, a worldwide website, which maybe millions of people every day and every time, and maybe in every hour, million of hits that got. And if this vulnerability exists for this website, so millions of users are going to get the same malicious response, and after that, that malicious response is going to executed on their user end, and everyone is going to be hacked. Because you can see here that you can also exploit the cross-site scripting via this vulnerability. So if you can exploit XSS, that means you can also steal the cookies, steal the password of the users, and if you get the password, then you get everything maybe. So that is the thing. Before packing up it, I would like to mention one more very important thing. As I mentioned here, that user will not feel that there is anything between me and the website, but there is cache. But we are hackers or we are testers, so we should know if there is cache in between us and website or not, or web server or not. So how we will know that the response are storing somewhere in the cache? There are many headers that indicates that the cache is being used between you and the web server. So if you are using nginx, so if the server is configured on nginx, so you will see that x cache status. Okay, if there is Cloudflare, so you will see if there is Cloudflare cache is used, you will see cf cache status. Fine. And there are others also, like x served or serve. We will see that maybe served or serve, I think serve, x served by. Okay, this header also indicate that the cache has been used. There is one more, which is x cache. Okay, and there is x vanish too, I think. Yeah. So if you find any of these header in the response, not in the request, in the response, if you find any of these header in the response, that means there is a cache in between you and the web server. There is another thing, that how you will know whether the response is served by the cache or directly by the website server. So let's see. Normally we get a response like this. In the response we find http slash 1.1 200 OK. Status code could be something else, but this is to make you understand. So suppose you get a response like this, and then let's say a content type, and the content type is, let's say, text slash HTML. Okay, and there are other headers too, response headers, and at last here you may find, let's say, one of these x cache header, suppose that you find, but the value of x cache header is miss. So if you see x cache header, you understand, okay, there is cache used between me and the web server. But if you find miss, that means the response is not coming from the cache. And if you find here hit, that means the response is coming from the cache. Okay, and once you get the hit, so there is another one which is age, and suppose that the cache store the response only for 60 seconds, so here you may find one more thing, which is max age, something like this, max age 60 seconds. Okay, and here once you get a hit, here you will find age is 1. 1 means from 60 second 1 second is already passed, or on the 1th second, on the 1st second you find the response, and maybe suppose that you find here 12 seconds. So that means first of all you get here hit, that means the response you get is from the cache, maximum age is 60 second, and on the 12th second you get the response. And if it goes 59, that means it is the last one, and in the next second if you make the request, you will again see here miss means because the 60 seconds has passed, so the cache will be cleared, and after this any first request come to access this website, cache will send this request directly to the backend web server response, and that response is cached here in the cache and also sent to the user. So after that any user come, it will be again you will see hit, and here you will find the time. So that's it for this video, and in the next video we are going to solve the lab number 1. And anything while solving the lab, I think I need to explain or brief again, so I will do it again and again. So thank you very much for watching this video. If you like the content, please like, subscribe and share. See you in the next video. Bye.